Hey, this is Steven from LegitTechTutorials, and welcome back to my product design series. We are back working on the multi-shooter expansion modules. So last we did the winder module here, and then that mounts onto the spool and the pulley bracket. So now what we're going to do is we're going to work on the pull and spooler bracket now that I have my motor of choice. So I have my motor of choice here. It is a 12 volt, 5 RPM, 12 so 12 volt, 5 RPM, and it has 30 kilograms per centimeter of torque. So let's go ahead and measure that out with a spool. So that is, we're looking at a maximum radius of 4 inches, and that's in centimeters. So let me jump out of Skype. Okay, so 4 inches is 10 centimeters, so 30 divided by 10 is obviously equal to 3 kilograms, which is equal to 6.6 pounds. And then at its least, we're looking at 1 1.25 inch, which is equal to 3.175. So that's obviously 10. 3.175. 9.44 kilograms, which is 20 pounds. 20 pounds of torque max. And then these are really nice. These only use 50 milliamps standard load at the 30 kilograms. And also the 30 kilograms, I believe, is the standard working torque. I don't think it's its stall torque. So its stall torque is a lot higher than that. So obviously we don't want this thing to stall, because then you're going to take away power from the other motor that is extruding. And on my particular dual H bridge, it is 2 amp limit per channel. So you need to be very careful with that. Make sure that you don't pull more, but my power supply is only 2 amps, so it's limiting that. Okay. First thing we're going to do is we're going to measure this motor. This motor is 1, let me double check, this is zeroed, okay. It is 1.460. 1.460. Okay. 1.460 inches. Oh, now. Okay, what happened there? First of all, this is 1.460. Whoa. Okay, I don't think that this thing is still horizontal. Horizontal. There we go. Okay, there it is. So now this guy should still be So this is 3.7. Yep. 3.7 centimeters. Yep. 1.46, right? 1.4. It's not exactly a perfect housing here. It's a little elliptical, but yeah. Okay, so now what we're going to do is we're going to work on the bolt pattern on this guy. Actually, let's delete that extra sketch. Let's do it on this guy. Okay. Alright, so now we're going to do the bolt pattern that holds this guy on there. So we have 1, 2, 3, 4 bolts. 2 are opposite, and then it kind of swings this way. So the main thing that I'm going to check is I'm going to look at what is the radius, because they should all be the same radius away from. Yeah, they're all the same radius away from the center. So yeah, let's take a look at that. Okay, so what I'm going to do is I'm going to do from the other side of this shaft to that shaft. Let me go ahead and show you guys the picture of what it looks like. So let me jump on my Amazon. I bought it from Amazon to get it here quickly. So here it is right here, and we have the 1, 2, 3, and so here's one part and here's the other part that I'm checking right now. So I can't check it using the calipers from this thing. So what I'm going to do is I'm going to mic it from this back corner, from the back side of this this thrust bearing here to this point, and then I'm just going to subtract half of the diameter of this piece here. So, from there to there, we're looking at 0.850. Okay, 0.850 from the center here. Straight up, straight down. Oops. 0.850 inches. Wait. How? Oh, this is 1.460. I think I probably did 460. Wait, what? Okay, oh yeah, that should be right then. 1.460. Oh yeah, I need to subtract the radius of this guy. Okay, so I said 0.850. Go to my calculator. 0.850. And then subtract half of this guy, which is 0.475. Minus half of 0.475. 475 divided by 2. Double check that. Yeah. That equals 0.6125. 0.6125. Alright, it looks good. And then again, the same direction back. 0.6125 inches. And then this is supposed to be horizontal. Okay. So that's that. And then we have, I guess you could say, to figure out the angle. I think these are around 30. Looks to be around 30 degrees from a 90. They should all be the same distance, but I'm going to double check. Yeah, they're all the same distance. Okay, so I'm going to guess. So now all you need to do is figure out the angle. So now with this guy, that was not straight across. So now my guess is this guy is going to be here, 0.6125 inch, and then it's maybe 15 degrees. So again, I'm looking at this hole right there, or this hole right there, so whatever this angle is. This is 90. This one's probably, I'm going to say 30. And then what I'll do is then I'll just measure these from one point to another and just make sure that those are the right distance from each other. So I'm going to say this is 30. Down. 30. For right now. Okay. We put 2 points, 1 point there, 1 point there. I'm going to measure the distance between this point, that point. 0.15558. Okay, so 0.15. So that's 1.558. It's 0.612 inches. Point 61. That's actually right on. Well, I guess they put some thought into this when they were reading it. Okay, so yeah, 30 degrees somehow. I guess exactly 30 degrees. Kind of funny. This one's 180 minus 30. I don't want to do any thinking right now 150 dirt. Okay, 0.16, no, 0.6125 was it? And this was 150. Alright, that looks good. Whoop. Put a point there. And let's go ahead and stop sketch. Find that original sketch. What is that? Sketch number 4. Display sketch number 4. Roll back to sketch number 4. So this was sketch number 4, and then there's the extrusion. Okay. And then this is where we'll put the holes. Oh, I forgot to put a point there. Okay. Alright, sketch number 4. Ready to go. Hole. Boom. Boom. I believe these are 3mm holes. I'm pretty sure. I'm going to have to check that. So if that's the case, let's just say 3mm right now. To this, to down. There you go. Okay. Let's make this 3, 4 right now. Oh, derp. That one I can't drill. So I spent all that time doing that one. I can't even do that one. Okay, maybe I should rotate this so then I can get all 3 bolts. It's a thought. We'll work on that. Alright. We're gonna go back to my electronics mounting plate and see what size holes those are, because those are M3s. These holes here. What size holes are these? 3.175. So yeah, I guess let's go ahead and we'll flip this. What I'll do right now is I'll just make them parallel to each other and I'll delete the other line. 15.558. This is 30 degrees. Or I can just do that. One 5.558, and this is 150. Keep that one there, delete that, delete that. Put 2 points, and then leave that one there. Stop sketch. There we go. And those are the holes that we need for that piece. Alright, what else do we have? We have 10 minutes. So let's go back to the spooler module and mess around with this winder module here. Alrighty. So again, I don't think this guy's gonna work. Let's go ahead and delete that sketch for right now. Sketch 4, that's good, we like that. Okay, so let's just create another sketch here. And then this one, we're gonna do the gear. So now what I realized from the last part is that we could actually not make the gear so big, because the gear only technically has to be a half gear, right? It only has to be like the top or the bottom portion of the gear. It doesn't have to be a full gear. So that way it's not protruding as much. It's just kind of like a flat, it's like a gear, but then you cut the top part off. So that being said, let's go ahead and design that. Of course, this is not really, it's probably going to have some backlash, obviously. I'm not 0.8890. Okay, let's first do a line 0.8890. 88. Okay. And then we need to do that thing again, 2 pi r, which we're not doing 2, we're just doing r. So 88.90 divided by pi. Oops. Oops. Right, 2 pi r, not doing the 2, just pi r. To determine r, I'm going to take the equal side divided by pi. So that's 28.2977. Okay, so then what I'm going to do is do a circle from that center point. .29. This is the radius, though. Circle. So it's a 56. And I know that this for sure is, oh, might not hit. So 56.595995497776. 595.595497776. There we go. All right, and then we're gonna just pick a side. Let's pick this side. I wish it would let me delete this portion. Maybe it will. Nope. Won't let me delete that arc. Anyways, so we're just going to do this bottom portion. And then what we're going to do is we're going to have the gears. Would the gears need to be popping out then? Or inside? They would need to be inside, I believe. Okay. This is 45. Okay. So let's just write a random template over there. So what I'm gonna do, this guy, 0.2404, 0.2404. Okay. So here's one of my little sketches, 0.2404. Okay. 2, 4, 2, 4, 0, 4, 45, negative 45. What? Yeah, these have to match up. So if it starts from this side, it needs one down, which means that this guy technically has to start from over there somewhere. Needs to start up here. Well, let's just keep going. Give me a second. Okay, so this is in. So yeah, so it's going to need to be flipped out. So I'll just do that temporarily. Okay. So then this is going to be from here this way. This is 45 degrees, and this is boom. So that's that little end there. And this is 2.44, and this is 45. And then these should be square. It should be, but it's not saying. Alright. And then I believe I'm gonna need... No, I should be able to just do circular tool off that. Okay. So then I need to do circular pattern tool. We're at 28 minutes. Circular pattern tool. Let me do boom, boom. And then center point. Oh, and then I need to do a full angle, 180. So yeah, it needs to go like that. I believe it should not hit fully right there. It's a little big on that side. So yeah, something like that. I don't know why these things are so small. Oops. Something is not right. This one's longer than that one somehow. I think it's because this guy is not pointed into the center. So it's tilted wrong. Okay. That's the point I know I need to go to, so what I'll do is I'll draw the line from here to that line. Yeah, there you go. Now it's tilted correctly. There we go. Okay, so now from there, this is going to go 2.404, 45. 45. And that's not 45 from the horizontal. From here. Two, 2.44. This one, 45, whatever. And then I'm gonna go and delete that. D dimension. Start using more hotkeys. 45. All right. Now, let's try that circular pattern again. And then I want it to do angle. Now these guys should line up now. Yeah. Look at that. That's what I'm talking about. So yeah, that was the issue I made. Oh, they're not perfect. Uh-oh. I mean, what is that though? Like half a millimeter or some shit. Let's do it for right now. And then what gap is this? .036 millimeters. Yeah, I'm not worried about that. Okay. And then this thing I think needs to be just a straight line there or something. Oops. Alright. Stop sketch. Extrude. Oh yeah, because these aren't complete. Wow. Yeah, that sucks. So maybe just decrease the angle. Can I do like a partial one? No. Yeah, I wonder if that's causing. Oops. 170. Oh, that looks pretty good. Okay, now I just need to drop the quantity over those meat. As long as it closes the geometry, that's fine. Wait, did I just exit sketch? That's not what I want to do. Okay, let's see how much these are overlapping. 0.05. Well, it's good for right now. We are over time by quite a bit. This is a 0.25 inch. Check it out. We got our half gear, and then we would have maybe an extra piece here where the hole is, blah, blah. Alright, so that's pretty much it for this video. So we got a few more things to do on this guy. We need to have like a bearing right on this guy, this side, a bearing right on this side, a bearing right on the bottom, wireless gear rights on top, and does the 180 sweep back and forth. We have to do that in their video. We were set up for our motor on the spool and pulley bracket, so we are ready to go. Thank you guys for watching. If you like this video, please subscribe for more videos like it in this series and our series as well. See you guys next video. Thanks for watching. Take it easy.